So once we have learned the slope formula, we would then be able to calculate the slope of a line using more than one technique. When you were given a graph like in example number 2, I can pick any 2 points on my graph, identify the coordinates, and calculate the slope that way. So in this case, if I have x1 and y1 for point number 1, and this is point number 2, I can calculate the slope using y1 minus y2 divided by x1 minus x2. I can probably come up with the same answer using 2 other points. You don't have to use the 2 points that is plotted on this graph. I can pick this point and that point. The slope between these 2 points will still be -2. Between these 2 points, it is going down by 2 units and then run by 1 unit. So you will still be getting the same slope at the end. You don't have to use the 2 points that I've chosen. You can use any 2 random points. But of course, you probably don't want to use a point here. You don't want to use a point there. They are in the middle of nowhere, and you don't have the coordinates for those. Or better yet, if they have the points plot on a graph like this, you can simply count the number of boxes to measure the rise and the run. You don't have to use the slope formula. And using the same concept, I can come up with the slope for the second one. I can pick any 2 points on the graph, and it seems like these 2 points are easy to identify. I can simply count the boxes to measure the rise and the run. And the slope in this case can be calculated using rise over run. And that simplifies to 1/2. For now, you may not see the benefit of using the slope formula. But once we start to use decimal value, fractions, square root number for your coordinates, you are going to see this advantage of using the slope formula to calculate the slope.